Okay, today this lab we're going to verify Bernoulli equation and continuity equation. Let's first talk about Bernoulli equation. So this is Bernoulli equation. It looks very scary. Actually, this is conservation of energy per unit volume. So that means if I multiply both sides of volume, this become work, this become kinetic energy, this become potential energy. So you see left side I put a 1 right here, and right side is 2. Then we're going to compare the energy conservation by 2 points. 1 point on the top of tank, and then the second point is 2 at orifice when the water flowing out. Later on I will show you these instruments. Anyways, so P is pressure, and because both 1 and 2 is both to the atmosphere pressure, so P1 equal to P2, so they cancel. And then density, here is a density of fluid, so all water, so cancel it also. So that I get this equation. So I'm going to move V2 here, and then move around the equation, I got this equation. So H1 is from the surface, this water, level of the water, from bottom tank to the level of the water, in the tank, H1. H2 from middle of the orifice to the bottom of the tank, the H2. So H1 minus H2 is at the H, from surface of the tank, water surface of tank to the middle of the surface, the orifice, I'm sorry. So H1 minus H2 each go to H. So I got this equation. So right now we're going to verify this equation, and then same way we're going to verify Bernoulli equation. How we verify this equation? So we always will measure the H. We will calculate a V2 square, and then we'll make a graph. So H is X here, V2 square is Y, because this linear equation. So the slope should be 2g. So in this experiment, you're going the data will show you H, and then you calculate H2 square and see if the slope close to equal to 2g. So if you use H is centimeter and G use 980. So if you use H meter, use G 9.8. And then we verify the Bernoulli equation if your slope is close to 2g. Okay, H, I will show you is this one. So, and then right now, let's talk about how are we going to find a V2 square. So V2 square, I'm going to projectile equation. So this is a big H. I'm sorry, I forgot this. Oh, here. So this is a big H. So the distance big H is from middle of the orifice to the bottom ruler. This ruler is not tank. So the range R is from under the orifice to the whatever the water heating to the ruler. Okay, so okay, I do some math right here. So I got a T2 equal to this. So this is how we're going to calculate a T2. V2. I'm sorry, V2. So we're going to calculate V2, and then this is your Y. H is this. Oh, okay, come on here. So so we're going to verify the continuity equation, second law, and then continuity equation is this. A1 V1 equal to A2 V2. So A1 is a area of the top one, and A2 is area of this orifice. So V1 is how fast and reducing in the tank, and the V2 is how fast shooting out. So, okay, I do some math. So A change to this, and then I got a D2 equal to D1 square root of V1 over V2. So V1 is the speed of the water in the tank. We're going to slow it down, and then V2 is how fast water shooting out. And then here I didn't explain that. So V1 I canceled it because V1 later on you see compare V2 is very small. So I ignored it. So that's why I got this equation.